Okay, so right now we're starting on slide 42, and in this unit we're going to be using what we learned about meiosis and sexual reproduction to predict the inheritance of traits. And so we're going to be using throughout this unit punnett squares, which are tools that you probably learned a little bit about in middle school, but we're going to enhance what you've learned about that. And a punnett square is a tool that actually models the process of meiosis and then the process of fertilization and sexual reproduction, and allows you to predict the likelihood of particular traits or particular alleles to be passed on to offspring. So if you look at the picture on the right on slide 42, you'll notice that on the top you have the mother's cell initially with a big A and a little a. And so this is for the A trait, the diploid number of chromosomes, 2 copies of the trait. And when that mother does meiosis, she will only pass on half of that, or one of those copies, to her offspring. And so when she makes eggs using meiosis, she could pass on the big A, or she could pass on the little a, and that's what's represented by the 2 egg cells on top of the punnett square. Same thing on the right side, you have the father that also happens to start with a big A and a little a in his cells. And when he does meiosis, he can produce 2 different types of sperm. He could pass on the big A, or he could pass on the little a. And when in the boxes of the punnett square, those egg and sperm are combined, that represents fertilization, and that shows the diploid zygote, so the diploid offspring. And so there's 4 boxes, which represents the 4 options of alleles that the offspring could have. So if you look at the boxes, there's a 50% chance of the offspring having a big A, little a, 25% chance of it having a big A, and a 25% chance, or a 1 in 4 chance of it having a little a, little a. So the boxes just show the probability of the offspring having different traits or different alleles based on what initially the parents pass on in their haploid gametes or haploid sex cells. Now if you can switch to slide 43 and continue. So in order to use meiosis and the initial cell that we start with the mother and the father to do punnett squares, we have to go through a couple of rules on how to do this. So if you look initially in the mother's and the father's cell, in this particular case, there are 4 chromosomes, 2 pairs of homologous chromosomes, and that would be the diploid number of chromosomes. And so when the mother and the father do meiosis, they'll pass on half of those, or 2 chromosomes. So in your egg and your sperm cells at the end of meiosis, for this particular case, there will be 2 chromosomes in each of the cells. Now, last unit, we looked at the process of meiosis 1 and then meiosis 2, looking at those steps to figure out how the alleles were divided up into the new sex cells. And we knew that how the chromosomes lined up in meiosis 1 would influence what were in the sex cells. Now, for punnett squares, we're going to kind of skip those middle steps and just do a quick jump down to the sex cells at the very end of meiosis 2. And how we know what alleles to put in those egg and sperm cells is there's kind of a quick trick. If you look at, for example, in the mother cell, the number of total B alleles, you'll see that there's 4. There's 4 sister chromatids, 4 Bs total. And if you look at the number of eggs, number of daughter cells at the end of meiosis, there's also 4 daughter cells. So if we were to go through the steps of meiosis 1 and then meiosis 2, what would actually happen is each of those 4 Bs would divide up evenly into the 4 cells. So there will be 1 B in each cell, meaning that when the mother passes on her traits to the offspring, she gives 1 copy of the B trait to the child. So if we look at the sperm, there's 4 Bs total again, but if the dad starts with big Bs and little b's, so 2 of his sperm cells could get a big B, while 2 of them could get a little b. So then we can also divide up our A's. So in both mom and dad, as there's 4 A's, 2 big, 2 little. So with 4 A's divided up into 4 cells, each of the sex cells at the end will get 1 A. So 2 of the cells will get a big A, and 2 of the cells will get a little a. And if you click through this slide till the end, till everything's filled in, you'll see that filled in the egg and sperm, and go ahead and fill that in your notes as well. And so looking at these cells, we have 2 different traits, the B trait and the A trait. But for right now, for punnett squares, we're just going to look at 1 trait or 1 allele at a time. So we're going to start just looking at the A's for right now. And so then we did step 2. We wrote down the alleles that will be in the egg and sperm after meiosis. So then we need to write down the allele options for the A trait, for the egg, and for the sperm. So if you look at each of those, there's 4 egg cells, and 2 of them look the same, and then 2 of them look different from those initial 2. So the allele options for the egg, the mom could pass on a big A if she gave one of the first 2 eggs to be fertilized, or she could pass on a little a if she used one of the second 2 eggs to go on to be fertilized. So those are the allele options for the egg, big A or little a. If we look at the sperm, in this case it's the same. Dad could pass on a big A if he used one of the first 2 sperm, or he could pass on a little a if he used the second 2 sperm. And so the allele options of the sperm are big A or little a as well. Now we'll go on to slide 44. And so we use those allele options from the egg and sperm to write the top and the sides of the Punnett square. The letters on the top represent the alleles possibilities from the egg. So the egg could be a big A or it could be a little a. And then the sperm goes on the side, as you see in the Punnett square on this slide. Also could be a big A or a little a. Now, it doesn't really matter if you put the mom or the dad on the top and sides, you'll get the same answer either way. So then when you combine the letters by bringing down what's on the top and what's on the side to fill in each of the boxes, that represents fertilization. So each of the boxes represents an offspring that received a copy of the A allele from the mom and a copy of the A allele from the dad. So there's 4 different options for offspring in this Punnett square. So now if you move on to slide 45, which will be the last slide we're doing today, we go back to that same initial cells from mom and dad, but now we're going to look at the B traits. So if you go back to the part of your notes where you filled in the egg and sperm cells, and now we're going to look at what are the allele options for the B trait for the egg and the sperm. If you look at the egg, each of the egg cells only have a big B. So the allele options to go on the top of the Punnett square would be a big B or also a big B. We'll list it twice to go with each of the boxes on the top of the Punnett square. So then on the side, we write the allele options for the dad. Now if you look at the sperm for the B trait, going back to your initial meiosis diagram, you'll notice that the first 2 sperm had a big B, so that would be one option for the sperm. And the second 2 sperm had a little b, so that would be the other option for the sperm. So on your Punnett square for the B traits, you should have big B on the top, and big B, little b on the side. So then fill in those boxes to represent fertilization, and in your note sheets, I want you to answer the question where it asks what different hair colors the babies could have. And you'll know this by using that trait information on this slide. It says big B gives you brown hair. Big B, little b gives you brown hair, and little b gives you blonde hair. And this is information that I would tell you you wouldn't have to know on your own. I would always give you that information. So fill in your Punnett square, figure out what different hair colors the children would have, and then that would be the end of the notes that we're doing today.